Hey everyone, thanks for tuning into my video on the Pythagorean Theorem. So the Pythagorean Theorem is something that kind of hits you in the face as soon as you enter kind of high school trigonometry and geometry when you're dealing with triangles and stuff like that. People have heard of the Pythagorean Theorem, but lots of the time they don't know what it is or kind of how it came to be. So the basic idea with the Pythagorean Theorem is that if you have a triangle, a right triangle, so a right triangle means that it has three sides, and one of the angles is 90 degrees. Okay, so 90 degrees just means it's perpendicular. So there's kind of a perfect cross section between the two. It goes straight down and then straight across. That's what 90 degrees means. Okay, so the Pythagorean theorem looks like this. It looks like a squared plus b squared equals c squared. Okay, so now we're kind of getting into the letter part of math, right? The variables. So it's not just numbers now. We're representing the side lengths of this triangle with A, B, and C. Okay, so the A and B, the order of them doesn't matter, okay, for all these questions, but the main idea is that this C is always the hypotenuse. Okay, so the hypotenuse of a triangle is just the longest side. Okay, it's always kind of opposite to the 90 degrees. So if you're looking for the hypotenuse, you always go to the 90-degree symbol here, and you just go straight across, and that's going to be the hypotenuse. So that's your C. So let's say this was 5. Okay? We know the hypotenuse has a unit length of 5. Okay, so I'm going to write equals. I'm just going to plug in 5 for C. Okay, let's say this length here was 4. Okay, I'm going to call that B. A and B doesn't matter because they're adding. The order that you add something doesn't really matter, but I'm just going to put 4 here, and we still have this A squared here. So the question might be asking, find the length of X. Okay, we know that this is a right triangle, and we know the side lengths 4 and 5. We can use the Pythagorean theorem to figure out what is this length of X going to be to make this triangle be able to have a side length of 4 and 5 for the other two legs. Okay, so A squared is just going to be our unknown side, or A, sorry, that's kind of like our X. So we can think of our A as our X. Okay, so A squared plus 4 squared, 4 squared is 16, right? That's going to equal 5 squared, so 5 squared is 25, all right? So, like the goal of this question, or the goal of this Pythagorean theorem, is to actually figure out what X is, or in this case, A, right? So, in order to figure out what A is, we have to move this 16 out of the way. So, see how if we subtract 16 on both sides, 16 minus 16 is just 0. So this part goes away. We're just left with A squared on the left side. And what you do on the left, you have to do it on the right. Okay, so the right side, we had 5 squared, it's going to be 25, and then we subtracted 16. So 25 minus 16 is going to be 9. Okay, so A squared, or X squared, right? A and X, it doesn't matter what you call it. The main idea is that it just represents this side length. So that side length squared is equal to 9. How can we figure out what A is, not just A squared? Well, just like how this was adding 16 and then we subtracted it to kind of get it out of the way because it's kind of the opposite operation. To get rid of this square, we just square root it. Okay, so the square root of a square is just what's on the inside. So now you're just going to be left with A. And if you do something on the left, you have to do it on the right. So we're going to square root the right side now. Okay, and that's going to be 3. Okay, so instead of X now, we can just write 3 here. And to kind of make sure that we're right, we can plug it back into the Pythagorean theorem and see if it all lines up. So if we're right, the square of this side, right, A squared, plus the square of this side, which is B squared, that should equal the square of this side, the hypotenuse, which is c squared. So let's just kind of plug it in and see. So 3 squared plus 4 squared, that should equal 5 squared. Okay, so 3 squared, that's going to be 9, right? 3 times 3. 4 squared, that's going to be plus 16. 5 squared, what's that? Well, that's 25. Okay, so 9 plus 16, that's 25. 25 equals 25. Since the left side equals the right side, we know we did it right. Okay, so this is what's known as a Pythagorean triplet. So anytime each side length is a whole number, meaning it doesn't have any decimals, it's just like 3, 4, 5, maybe 12, 13, 2, numbers like that. Anytime each side length is a whole number, that's what's called a Pythagorean triplet. So it's kind of a ideal triangle. Sometimes it's not going to be ideal. So let's say we had a triangle that was like maybe the bottom here was a bit longer like that, right? Let's say this was 6. Let's say this was 10, right? How could we figure out what this side length, this hypotenuse x is going to be? Okay, so this time we're looking for c squared. Because remember, if this is 90 degrees, our c, or our hypotenuse, is always going to be opposite to that 90 degrees. So if we write out our Pythagorean theorem, right, a squared plus b squared equals c squared, we're just going to be able to plug in these numbers here. So what we don't know is c squared, because x is our c, it's our hypotenuse. So we know that a is going to be 6, b is going to be 10, so let's just plug that in. 6 squared plus 10 squared, okay, that's going to equal c squared. Notice how I didn't plug anything in for c because I don't know what it is. That's what our x is, that's what we're trying to find in this equation. Okay, so let's simplify this a bit. 6 squared, that's just 6 times 6, right? So that's 36. Okay, and then we're going to add 10 squared. Okay, so if we add 10 squared, that's going to be 100. Because remember, 10 squared is just 10 times 10. And 10 times 10 is 100. So that's going to equal our, that's going to equal our c squared. Okay, so in the last question we did, we had to move a term on the left to the right side, right? Because remember, it was 9 plus 16. We had to subtract 16 on both sides. This time we don't need to do that because the thing that we're looking for is already on the right side. It's already on its own. Okay, so all we need to do is add these two things together. So 36 plus 100 is 136. And that's going to equal c squared. Okay. Now, just like in the last question, we have c squared isolated, right? It's on its own. But we just want c because the thing we were looking for was our x, right? And if we're looking for x, we don't want x squared, we just want x. So how can we get rid of this square here? Well, we can square root both sides because remember, the opposite of a square is a square root. So on the right side, we're going to get c, and on the left side, we're going to get about 11.7. So see how this is a decimal here? Whenever you get a decimal for one of your side lengths, that means it's not a Pythagorean triplet. It doesn't mean you're wrong. It just means it's not a great number to deal with, but that's okay. And anytime you have a question like this, right, you can kind of check, like if you get a question like this on a quiz or a test, if you get, let's say you did something wrong and you got 300 for this side length, you can kind of look at these side lengths and ask yourself if your answer makes sense. So if you got a super huge number for the hypotenuse, but these were smaller numbers like 6 and 10, you know you probably made a mistake somewhere along the way. So you just go back, figure out the mistake. Once you have the answer you think is right, so in this case it's going to be 11.7, you can kind of check it again and say, okay, this is 6, right? This is 10, so it's almost twice as long as the shorter side, right? And this 11.7, it's the hypotenuse, so it's got to be the longest side, but it doesn't look much longer than 10. It's definitely longer, but maybe 1 or 2 units more. So 10 compared to 11.7, yeah, that looks about right. So we can kind of figure it out that way as well. We can't guess 11.7, but once we have our answer 11.7, we can compare it to how the triangle looks. Okay, and we can verify it the exact same way. So I just want to finish off this video by listing some Pythagorean triplets. Okay, so remember, Pythagorean triplets were um, kind of situations where we had a triangle like this, and the side lengths were all whole numbers. Okay, so in this question, it was 3, 4, and 5. It kind of worked out perfectly. It's the perfect situation. This question wasn't a Pythagorean triplet because 11.7 wasn't a whole number, but I'm just going to list some off here. So 3, 4, and 5 is a super common one. Okay, so if you have a triangle with side length 3, triangle side length 4, and a side length 5, that's a possibility. And remember, this was the question that we did first. So this is one Pythagorean triplet. That's kind of a set there. Another one is 5, 12, and 13. So if you have a triangle with a side length 5, triangle with a side length 12, you know that this last one's going to be 13. So this is 5, 12, 13. You could use it, or you could figure that out using the Pythagorean theorem, but it's just been kind of helpful for me personally to know the Pythagorean triplets, because in class when everyone else was trying to figure out what's this hypotenuse length going to be, I already know my Pythagorean triplets. I memorized them. So if I have a side length 5, side length 12, it's a right triangle, I know it's going to be 13. Okay, a couple other handy ones to know is 20, 21, and 29, right? We can multiply everything in here by 2, the 3, 4, and 5, so we can just get 6, 8, and 10, right? You can multiply any of these by any number. As long as you multiply every number by the same thing, that's going to be a Pythagorean triplet as well. And honestly, after that, you probably don't need to know um, any more than that, because these are kind of the common ones. So 3, 4, 5, 5, 12, 13, 20, 21, 29, 6, 8, 10. If you can remember those 4 triplets, I think you're going to be way ahead of your classmates in terms of your knowledge of triangles and how quick you can solve these problems. So I hope that helped. Kind of gives you an introduction into the Pythagorean theorem, how you can use it. There's lots of questions that use the Pythagorean theorem. Like for example, if you start in a certain location, right, and you walk straight up and then you walk straight to the right, we could figure out your total distance that you've walked, right? This is your hypotenuse, and we have our little right triangle going on here. So it's kind of a useful tool to have. It's not completely useless. And yeah, I hope this video helped, and I'll see you in my next one.